Hello all, my name is Pavitra. Here we are to discuss about a project, graph representations of personal and criminal networks. So coming to the project client details, we have been working with our client, Suresh Sod from Knowledge Management, and our supervisor is Akanksha Sharma. Dr. Suresh Sood is the supervisor assigned to the industry and support the project with his expertise and ongoing research partnerships. He is also an expert in machine learning and massive unstructured data with background in retail, financial, and law enforcement like industries. And also coming to this project overview, this project spans 2 trimesters focusing on analyzing social and criminal networks using graph databases and visualization tools. The use of graph databases and social network analysis to analyze individual and criminal connections, focusing on practical data set such as LinkedIn relationships and the criminal data sets, which are Panama Papers, poll data model, and cash fraud detection. It focuses on accountants and forensic experts to identify new revenue opportunities and enhance investigation skills using Neo4j and Kumu. The next part will be continued by my friend Moin.
Hi everyone, I am Mohammad Moin. I am going to explain about the client requirement. Basically, in our project, the client was looking for a tool to study the connections in networks through visual graph designs. Like basically in our daily life, he is looking like for we need to find the connections between by using the entities between the criminal data or the personal LinkedIn data. So here he ensured that team members can view their LinkedIn networks in Kumu as well as criminal networks using New 4J. And these the tree maps and bar charts where Google Colab and Plotlib are described. And finally, he required the screen recordings and voiceovers explain insights and findings. And coming to the next slide regarding the project design and approaches, here the project design is basically used to gather the professional data from LinkedIn of all our team members. And here we use the 8 data sets. Like we have collected 8 data sets from Excel sheets of LinkedIn. And here we used Python coding with PyCharm software, including pandas libraries and collapse libraries, then combine them as one data set to get the nodes and edges files. And after getting the nodes and edges files, we have used the Kumu .io to visualize and combine the team members' LinkedIn networks, documenting insights and benefits. And by using the Kumo software, we can upload the nodes and edges to get output of all our LinkedIn data connections. And then we are applying plotly.ly to create positions and company concentric network visualizations. And the other part will be discussed by Malinka.
Okay, thanks, Moin. So I'm Malinka, and my part is to show the results of the LinkedIn data. In here, we have what Moin said was we have collected 8 data sets, and this is how the results of the 8 data set looks like. So in here, the project successfully achieved its objectives of mapping and assessing individual networks on LinkedIn, and then finally there's a complete visualization view of the LinkedIn data, so like we can filter it by organization level and connected on that is like when they are connected to the LinkedIn through email addresses as well as owner, and as well as position wise we can view a complete visualization of the LinkedIn data. So moreover, we can see some more visualization by the link when you go on to driver's Google Drive link. And the next part too is about criminal networks. So in here, criminal network investigation, it is our second phase of the project. This involves analyzing dataset that were more complex and unstructured. So, for the criminal data sources, we have used the Panama Papers, which expose offshore financial organization and connection. And the next one is the POL framework, that is standing for person, object, location, and event for organizing crime related information. And the next source is about the whiplash for compensation. That is a case study of the widespread insurance fraud schema known as whiplash for cash. So, in order to do that, we have used some tools and technologies. We have used Neo4j, which is a graph database that is well suited for modeling the relationship between nodes. And then for Neo4j, we have used Cypher query language, that is to utilize and retrieve data related to the crime networks. And for the POL model, we have used it in an organized format for disorganized data. And also, when we are going to analyze of Panama Papers, we have importing pre-processed CSV data into Neo4j. There we have obtained nodes as address-wise, individual-wise, and organization-wise. Relationship shown by owns registered in connected on, and identified shell companies and suspicions connection. So that's how the analysis of Panama Papers have been done. And in the POL model, it goes as person who is involved in and in some event, and how that person is connected to that event, and the object and the location the incident has happened. So this used to expose the criminal gangs and patterns of recurrent fraud. Then the next is the case study of the whiplash for cash. That is also an analysis of insurance fraud network. There we are going to see the recurring claims from the same address, and also analyzing the graph reveal potential suspicions and highly connected nodes with it. So that's how all these three criminal data has been analyzed in our projects. So next, my colleague Saket will explain from here onwards.
Hi guys, myself Saket. Coming to the testing and validation. So here we worked with Panama Papers dataset using Neo4j. We ran the queries to pull data about offices and entitles involved. This helped us map out relationships between individuals and offshore companies. Even the results were limited, they revealed how these peoples were linked to shell companies. That's often used to hide illegal financial activities. Next slide. Yeah. Coming to the POL data model. In this part, we applied the POL model, which stands for person, object, location, and event using Neo4j. We ran queries to explore police investigation. For example, we looked at how one person was connected to drug crimes through social media. This showed how the graph analysis can uncover hidden connections between suspects and criminal events that are obvious in traditional databases. Now, coming to the next slide. Results for cash fraud detection. This section focused on detecting fraud using car accident data. We acquired links between people, vehicles, and accidental records. By doing this, we are able to find patterns like some individuals or cars showing up in multiple incidents. This helped us identify possible fraud risks where people might be collaborating on faking the fake file insurance claims. Now, coming to the comparative analysis. Finally, we compared all our databases like LinkedIn, Panama Papers, poll model, and fraud data. Each one required a data approach depending on its structure, but across all of them, graph analysis helped us reveal deeper insights and hidden connections. This shows how powerful and adaptable method is, whether it's for social networks or financial crime or criminal investigations. Next slides will be explained by Abhishek.
Yeah, thanks, Saket. So coming to me, I was majorly dealing with the conclusion, documentation, and question and answers for our project. So coming to end of our project, we have found various conclusions depend upon how data complexity, how tool limitations, how human insights and future opportunities can be discussed. Coming to the first point regarding data complexity, a large amount of computing power and specialized knowledge is required to handle such complex and unstructured data sets is what we realized by from this project. We also came with an output where certain visualizations tools do not provide integration or the ability to scale effectively for large network data. And also coming to the insights from this, we have found that human researchers continue to be vital for understanding patterns and irregularities, even with advancements in AI technology. And also in the future, if graph databases present significant opportunities for business and law enforcement users with additional advancements. So coming to, if you look on a broader scale of our project regarding creativity innovation, so this employing innovative graph analytic techniques to reveal concealed connections within the intricate networks. And we are also utilizing artificial intelligence, cloud technology, and graph databases to convert data into practical insights. And also, if you understand the impact on the entrepreneurial side, it's creating new consulting services and research tools that generate income and enhance results. Yeah, so that's what our project is all about. And also we have attached references for in the slide number 17 for all our open LinkedIn data sets or open criminal data sets and everything. Thank you guys.
Thank you.